Hello and welcome to this repair tutorial, and today we're going to look at a Marantz and the model number is 7200. In terms of general specifications, power output when the amplifier is running in class AB mode is 95 watts per channel RMS, and that's 2 times 8 ohm speakers. If you select the class A mode from the front, then this will reduce to 25 watts RMS, but again 2 times 8 ohm speakers. And with this amplifier, again, if you wish, you can have 2 sets of speakers connected. So you can select between system 1 and then system 2, or both, or for personal listening, you can switch them both off and then just use the 1/4 inch jack socket on the front to connect headphones. If you wish, you can bypass the tone control circuits by pressing the direct mode, and then frequency response is 20 Hz to 20 kHz. Total harmonic distortion comes in at 0.03%. And then if you're connecting a turntable with a moving magnet type cartridge, your input sensitivity is 2.5 millivolts. And then for all of your other line inputs, it is 150 millivolts. Then in terms of dimensions, width is 440 by a height of 159 and then a depth of 275.4. This amplifier is quite weighty at 12.3 kilograms. Now, this amplifier came in from a customer, and the customer had seen a number of repair tutorials which I'd done previously, and what he described was, well, really multiple issues with the amplifier. So there was this sort of it was like a crackling noise that was coming through on the channels, and then you sort of had intermittent loss of sound on the right hand channel, and sometimes it would come, sometimes it would go, and sometimes it would be more associated that when the amplifier was warm. So here, this is before the amplifier was stripped down and all the work carried out. And you can see again, this is very common. There's quite a lot of layers of dust on all of the circuit boards, but nothing to be concerned about. There wasn't any issue here associated with the amplifier being in a damp environment. So it's relatively straightforward to clean off just that dust from the amp. Now, if we look from the rear of the amplifier, and you've seen this on other tutorials for the same model of amplifier, I'm just making reference to a couple of areas. The first one on the left hand side is that normally you should have links installed which will connect the preamplifier section of the amplifier to the power stage. And it's not unusual for these links to be missing, because maybe the customer or the owner had chosen just a different input and output configuration. So they may well have driven the preamplifier output into additional power amplifiers, or maybe there's another preamplifier that they then drove into the power stage. These amplifiers use a common ground connection. So when you look from the speaker terminals, there is these center screws, and that's why there's no paint on there, because it has to make an electrical connection. And the reason why this is important is once you've repaired the amplifier and you're coming to the point where you need to test it, you just to make sure that this back panel is on and that you have these grounding screws fitted. If you don't, then it could result in damage to the circuit board. So these screws must be in place. So it's not an error on Marantz's part that these are not painted. That's done deliberately to provide that ground connection. And then if we look from the top, what you can see, this is the input selection boards, and it also is the secondary board where you have the link connectors as well. And if we remove that circuit board to look at it in more detail, you have the ribbon cable which is coming from the front control board, and then you also will find that there is a multi-pin connector which is just taking the audio from this input selection. So there is no mechanical switch, there is no custom or solid state integrated circuit doing the input selection. These red rectangular objects are switching relays, and the microprocessor in turn will switch the appropriate input depending on what the customer selects. So that could be via the front fascia, or maybe they are using the remote control. Now, for anyone who has been following the channel for a period of time, you'll be familiar with the routine that you have to go through for this make of amplifier, and you can apply it to all Marantz amplifiers of this era. And what I've done, as always, is I'll put some circles around key areas that you need to focus on, and you're going to have to re-solder every single circuit board in this amplifier before you get to do any sort of measurement and then testing. But the good thing is, if you follow this tutorial and you do all of this re-soldering, virtually in all cases you will resolve the issue associated with intermittent loss of sound and crackling noises and popping sounds and all of that, because these dry joints are throughout. Once that circuit board was then re-soldered, here what you can see is the main circuit board, and again what I've done is I've just highlighted a number of areas. Now you need to take your time on this, right, for two reasons. The first one is every bad solder crack or joint is a potential problem or a failure. So if you rush it, you may not see a solder joint that you should have reflowed or resoldered. And then the other part is, and this is very, very common, if you're doing the resoldering, what you'll find is that some of these components are very, very close together. And it is easy to accidentally make a solder bridge, and then if you install the circuit board back in and then you then test it, you're going to have issues. So what I always say is you have to make the time, don't rush it, okay? And then you have to take the time. Every time you are doing this work, just verify the quality of that. Just scan that board and make sure that there are no solder bridges at all. Now the good thing with this amplifier is it's extremely modular. So if you are making any sort of repair work on it, it's very easy just to remove the different modules and then pop them to one side and then work on a particular section at a time. So here what I've done is I've removed the input selection boards. That should have been on the left hand side, and you can see the flex connector and then the signal wires. And then what I've also done is I've removed the main amplifier, and then when you look from the rear you can see here the power transformer in the center, and that's a high quality transformer. I've never had any experiences where any of those transformers have then failed. And then on the left hand side, and we'll get into this in a little bit more detail, this is the lower voltage power supply, which is providing of course also to the preamplifier section. You have the volume and input audio processing side, the front board which has the microcontroller on there, input selection, LED indication, etc. And then the right hand side you have the power supply with the substantially large electrolytic capacitors, and also the lower voltage power supply as well for the microcontroller. Now in this photograph what I've done is I've put the rest of the amplifier to one side, and this is the amplifier. And what you can see are the large heat sinks left and right, and then towards the rear of the amplifier, and I'll show you another photograph a little later, are the speaker protection relays. And because you can have two sets, then there's a relay for system 1 and then system 2, and these are double pole 24 volt changeover relays. And then the vertical circuit board is the protection board, and then when you look towards the front you can see they look like bronze covers, and that's the input signal processing part of the amplifier. So that's where you would find the transistors associated if you had, an issue with DC offset. And you can sort of just about make out the trimmers just in front of there. They're used to eliminate the DC offset, and then we'll show you a little bit later that there are two other sets of trimmers left and right to set up the current for the AB mode, and then also the class A mode. Now when I spin the board over, this is the main area of focus, and you're going to have to spend a substantial amount of time resoldering every single component on this board. And as I said, just make the time and take the time. Dead easy to get a solder bridge, and you have to check every single solder connection to ensure that it's good after you've done the resolder. And then here, if we focus in a little bit more detail, I've circled the speaker protection relays. So again, these were replaced because the contacts become oxidized and also resistive and cause problems with distortion and loss of sound. And then the circuit board, which we mentioned a moment ago, just plugs in. You just remove this plastic locking clamp by a single screw, and then you can then unplug it. The reason why this is important is here on this photograph, this is the board turned over, and I've circled areas. So you'll find it on the multi-pin connectors, dry solder joints, and then also on the dedicated protection IC, and you just need to do all of that resoldering. And then here we take an aerial shot, and the board which is closest to us, that is the large power supply, and what you can see is there's a smaller EI transformer, and that is used for the startup. There's also a power relay as well, which is driven of course from the microcontroller, and then you have two large canisters as they look, and these are the electrolytic smoothing capacitors. And there is also a smaller lower voltage power supply on there, and you also have a relay. We'll speak about the relay in a moment. And then here you can see that I've put an arrow, and this is pointing to this relay. Now the significance of this is that this relay operates when you select the Class A mode. So what will happen is that the supply voltage to the power output stages of the amplifier will be reduced. And what I've done is I've put a link in the description to the video for the other PM7200 repair videos, so you can, if you have the chance, just to go back to them and then you can see that in more detail. You can also make out as well that there are 4 individual smaller Wickman type fuses on there, but that's on the circuit board, and then you also have the larger bridge rectifier as well. Now when I turn over that circuit board, again you will find that there are multiple dry solder joints. You'll find it on the rear input socket and then also on the individual diodes. And what you'll have to do, and where I've put the yellow circle, is you're going to need to desolder that power relay because the contacts on there will have become oxidized. And on this photograph you can see that I've removed the relay, I've taken off the top cover, and what I'll do is, again non-abrasive, I will clean the switching contacts just to remove that oxidization, and it just ensures clean operation. And then here again I put an arrow, and what that is doing is it is pointing to the motorized volume control, and it's quite a complicated volume control. So what I mean there is you don't have, for example, just a dual gang potentiometer. It's actually dual gang, so there's 2 dual gang potentiometers connected together on the same shaft, and then in turn it connects mechanically to the gearbox, which is where you're seeing there, and then the motor on the rear. And that circuit board there plugs directly in to the board at the bottom, as you see, and this is containing the power supply then for the tone and also to some degree the signal processing. And if we just look from the left hand side, you can see that I'll put a circle around, and those are the pins of the potentiometer, and you'll always find dry solder joints there. And then also the lower part where you see the circle, this is where it's the multi-pin connector, and it connects then to the board. Now what you will need to do is you'll need to remove the front fascia stroke tone board, and again you will find on here multiple dry solder connections. So you have the low voltage power supplies, and you'll find dry solder joints on the voltage regulators, and then you also have these multi-pin switches as well, so you'll find cracks around there. And then the ones towards the top part of this photograph is where you have the balance controls and the bass and the treble. You'll normally find cracking around the pins there of those potentiometers, so you can then resolder those. But this amplifier did have another issue, and that's what I'm highlighting here. When that board plugs in, there is a stand-up pillar and protrudes through. Now I don't know if this was done during manufacture or it come at some point later, but any of these holes are potential stress points. So all I can conclude here is that at some point in time excess pressure either came from underneath or from the top, and that resulted in just a hairline crack going across. And then what has happened is it's cracked slightly the board, but if you then follow it along, and you can just use your fingernail, what you could find is that the circuit board was damaged. It was actually cracked across the circuit tracks. And I always advise this. What you don't want to do is just to scrape off the coating to expose the bare copper, and just simply take your soldering iron and just flow across some solder. That is mechanically not a good repair. What you should do is just take some small, and they can be cut off leads from components, resistors or capacitors, and just solder across that cracked track the link wire. And then on this shot what I've focused on is the headphone socket, and then you can also see that there's some smaller multi-pin switches, and these are where you select system 1 and system 2. When that happens, it also will operate the rear relays, and I'm just making sure this board is good. There's no concerns with regard to connections. So once that has all been done, and you also spray into the volume control and then also into the push button switches as well, De-Oxit D5, and operate multiple times just to ensure that any dirt is not going to cause you any issues. And that was all done. And then we then come to really an overview for the alignment procedure, and it is straightforward, it's not complicated. So here we show a left channel circuit schematic, and you have the input stage for the signal processing, and then we also have the driver stage, and then finally the main output stage. And as we said before, we have the preamplifier and then the main amplifier section. So what is it that you're looking to do? Well, you're looking to make 3 adjustments. The first one is that I need to adjust the DC offset on each of the channels, so left and right. I then need to select from the front class AB mode, and again I need to set the millivoltage. But when you do this, just make sure that you have system 1 or system 2 selected on the front fascia, and then that connects, of course, the output stage of the amplifier to the rear binding posts. And then the final part is, once that has been done, you will then select class A mode, and then we will need to adjust it until you are reading 90 millivolts. And I'll show you where you make the connections in the next shot. So here, when we look from the top, what I've done is I've just put a series of circles. So where you see the yellow circle, that is one of the emitter resistors. And what you will do, and again I will show you this, you need to connect your multimeter hook clips, and that's where you're going to be measuring the current flowing through the output transistors of the amp. And then I've put the circles around the preset potentiometers. So as we said before, you can adjust then the DC offset, and it's also marked onto the board where it will say A and then AB mode. And then when we look to do the DC offset, if you look here to the right hand side, what I've done is I've just connected my multimeter probe leads to the speaker binding posts, and then what I'll be doing is no signal input connected, of course no speakers connected. Here, making sure that the bass, treble and balance controls are all at midpoint, and I'm making the adjustment until I'm reading 0 millivolts or thereabouts. Okay, there's a small amount of tolerance, but on this amplifier, it's not a hard adjustment to make, and you should pretty much get it to 0 millivolts. And then here, what you can see is that the DC offset was quite high on one of the channels. So when we measured this on the left hand channel, it was about 10.8 millivolts. And then after the adjustment, you can see now that that's really low, and it's just above 1 millivolt, which is perfect. And then here, then I'm not showing the pre, but this is after, where I'm now showing you that the other channel as well is down to just under -1 millivolts. So fantastic in terms of eliminating any DC offset for the amp. And then when you come in to do your adjustment for the AB and then also the class A current, bias current, you can see what I've done is I've just connected my multimeter on the end terminals for the emitter resistor, and you can see that when we are doing the measurement in AB mode, it's slightly high, so you're up around 23.45 millivolts, and then we make the adjustment and you can see that we're slightly above 18 millivolts, and you just need to make a small adjustment. Just wait for the amplifier to stabilize, and if you just take your time, you'll get it pretty much bang on. And then here, then for the next channel, you can see it's at 18.12 millivolts. And then what I do is I just select then class A mode, and in class A mode, as you saw from the circuit schematic, it should be reading 90 millivolts or thereabouts. But this is common, and you see this, you can see that it's quite high. And this is really happened just because of component drift and then aging on the amplifier. So as part of the alignment procedure, we're just taking it back to the original values that it should have been at when it left the factory. So once we've made the adjustment, you can see that we're at 90.07 millivolts, which again is great. And then if we look then at the other channel, and this is the right hand channel now, you can see that we're just slightly under 90 millivolts at 89.80 millivolts. So that amplifier now has been fully aligned. Also the joints have been re-soldered, and then also the speaker protection relays have been replaced. And as we said, all switches, potentiometers have been cleaned with De-Oxit. And then if we look from the top, you can see that the new relays have been installed. The boards have all been cleaned as well. And as we said, this amplifier really will, deliver many years of listening pleasure for the owner. And then the only final stage, as with all service and repairs, is just to carry out the necessary tests. So we just monitor to make sure there's no underlying distortion, which there wasn't, and the amplifier goes onto a soak test for 3 to 4 hours, and it performed faultlessly. And it's a really nice amplifier, said before on previous tutorials, I totally understand why, you know, customers or owners out there will seek to have these amplifiers restored. And as I said, as long as you follow along with this tutorial, you will be able to restore it yourselves. In terms of time as well, this amplifier to do all of this work would normally be about 4 hours. And then if you added in time, for example, from unpackaging the amplifier, repackaging it up, cleaning it, you're probably getting close to 5 hours in total. So, you know, rewarding in itself, but nothing that you can just rush through. So that really brings us to the end of this repair tutorial. And as always, I appreciate you stopping by. And if you need any help, guidance or assistance, by all means email audioamplifierservicing@aol.com and I'll be more than happy to help and support. So until the next time, I wish you all the very best. Cheers and bye-bye.